to obfuscate it, so to make more difficult network analysis. So today I'm going to tell you about some interesting, tricky obfuscation techniques for C2 communication in the network, and I will show you how we can detect them all. But I want to ask you, is there a lot of people or few people who works in network analysis? So just raise the hand, just interesting for me. Okay, I'm glad that there are some people. So now a few words about me. I'm a malware analyst. I work more than 5 years in researching, detecting some different threats in the network. My first work connected with web threats, with skimmers. After that, I started to detect all malware and some attacks in the network. So I try to improve some network traffic analysis tools. I search for new approaches to detect network threats, so I make a lot of work in the network. Also, I finished my bachelor and master program in cybersecurity. I finished my master last year. I played CTF many times. I participate, for example, in Black Hat MIA, Middle East and Africa, in CTF. It was interesting experience. So now I don't have enough time for CTF because a lot of work, a lot of malware in the network. So also I teach students, or organize some cybersecurity events, but I think the most interesting for me, like for researcher, I try to share my research on the Twitter platform about some new interesting samples, malware, and I try to show traffic which I found. So if you're interested, you can subscribe and see. Now we can begin. Report plan, you can see on the screen. Firstly, in the first part, I will tell you about some network basics. I guess all of you know about how internet works, but I want to show you where and how network analysis can be used. So we will see it. In the second part, I will show you some methods for analyzing, detecting some suspicious, dangerous malware activity. And the last part of my speech, I think the most interesting part, because it's called, my speech called, obfuscation techniques for C2 communication. So I will show you some interesting and the most popular used by hackers techniques, and we can see how we can detect it by various methods. So the first part. Here you can see just the theme, how packets sent. I think that you know about chunks, streams that have to get routed to through some technical tools. So it doesn't have sense now. So where we can have network analysis here. There are a lot of network security solutions. You can see on the screen firewall, NGV, DLP, some IDS IPS systems, and there. Some of them can check internal packets, some of them external. Some tools have some detection, MITM, decryption. So some have more functionalities, some have less functionalities. But we, network analysts or network engineers, try to make all our expertise for these solutions and products. We try to add some expertise for monitoring, analyzing, and for detecting. So how we can do it. There are some methods which we use for analyze and detect this not good activity. So I think that all of you know about pyramid of pain, which illustrates some IOX levels. But here, I make a pyramid of network traffic analysis technologies. So I will tell you about every of these technologies. So let's start. The first one and the most easy of all is reputation lists. I mean some URLs, domains and hashes, etc. So it's just some blacklist, whitelist. For example, I think you know Old House, Threadfox, some phishing resources, also GitHub. There are a lot of lists with IOX and sure VirusTotal, where we can also track and know about what is the resource, is good or bad. But what is disadvantage of this method is that it's not actual. Every day there are a lot of domains, new IP addresses for malware communication, and it's really easy for hackers to change them. So I think it's good to use in some solutions this method, reputation lists, but it's not enough for using, and you need to use another methods. So, which signature analysis? It's also simple, but I think it's more interesting because you can detect not just domains and something which can change easy. Signature analysis is network tools. I think all of you know about Suricata rules. So here example. I think you see not well and from the end of the hall, but here just example from one network rule from emergent threats open rule set. This rule is written on unknown loader, and it contains some content with plain text, which used by this loader, for example, system info, host name, current user, etc. There is also PCRE, it's regex, which make this rule more flexible, but hackers can change content, so it's not the best decision how we can find this loader. But it's typical rule. I also write a lot of similar rules, but sometimes I see, and from guys from emergent threats, from my colleagues, from me, so difficult rules for understanding, which contains a lot of specific keywords from some ancient languages. It's not only Suricata, there are also Snore, there are a lot of custom engines, so they contain a lot of who work in network analysis. They know by test, by jump, when you need to check bytes, and they place in a packet with some threshold for bits, so really a lot. And it's difficult to understand for which packets this rule, and you need to spend some time for understanding. So there are some open rule sets. I make some small research to find them, because I think about emergent threats a lot of people know, but about others, not a lot. So there are some power patrols, also positive technologies open rule sets. These three first rule sets, they are updated regularly, but also there are other, for example, threat hunting rules, lateral movement rules, but they no updates from some date. So you can, if you're interested, you can use these rule sets for try to find something. It's really easy to install and use. The next method is use some sandboxes. When you see in the network traffic some files, you can make collaboration with open sandbox or with your sandbox and check this file, not in traffic, but about its behavior. So this method is more difficult than signature analysis or reputation lists, but it really can help to understand, because not always you can understand is malware or not, just when you see on network bytes. And I think you know AnyRun, Joy Sandbox, Triage, there are a lot of other sandboxes, for example, Meltdown, Gibrit Analysis, and others. So it's really easy to use it and check malware. And also from these sandboxes, you can download pickup files, also with SSL case for decrypting. So it's really interesting to check and research. And the last one is advanced analysis. Is about some various techniques. So we can use all of them. I will describe you about each. This is the most difficult method, I think, because here you need to find malware using more difficult decision. So fuzzy search. Fuzzy search is about some mathematical calculations, make big numbers using some functions, fuzzy hash functions. There are a lot of Hamming code, weights, Fourier, etc. So it's really good method to find new malware. And for clustering, when you have a lot of packets and you need to make clusterization of all these packets, you can use this method, but it also can give falses. It's okay, and you cannot change it because it's not about just plain text like reputation list or signature analysis. It's more generic method. Other method is ML solutions. You know about it. Here also you can have big number of packets. After this, you can just make some teach your model using these packets, using some features. So here, small image from example, my research. I made ML model for finding malware in the network in HTTP protocol. So it really works, but also there are some falses, FP. So yeah. Other method is behavioral profiling. Just imagine you have a network and hundreds endpoints which connected to this network, and you need to understand how we can find malware in this. So we can make a behavioral profile for each endpoint or for some of endpoints, and understand, for example, at which time some person works in by this endpoint. And if there will be some network communication, a lot of packets in time in which a person usually doesn't work, it's weird. Yeah, I know that there are some situations when you need to work not in time when you work usually, but this method can check this situation and understand that there are. So it also can used in collaboration, for example, with ML solutions or fuzzy search for finding some suspicious activity in the network where a lot of points. And the last one from advanced analysis method is script models. It's not only Lua, just I think you know about Lua. Here I just want to show you that you can write a lot of, you can write some scripts, some code, which will help you to find some activities which you cannot detect using some usual network rules. I mean, if you need to check some bytes but you haven't keyboard in this rule, you need to use script and write script models, and after add it to some solutions. For example, it's not ML, it's about some algorithms, but it really can help. And the third part, the big one, about which techniques for secure communication we can use. I will show you some examples how we can detect it. Not a lot. So, for example, for first example, I will show you detailed rules, but for other methods, I will not show you detailed because we don't have enough time, but I try to make you more understandable about some techniques. And the first one is mimicry of legitimate communications. Here you can see screenshots. Yeah, it's not big one, but okay. This malware is backdoored on shell. It's not new, but here you can see and understand how it can work, what is mimicry, because there are a lot of legitimate communications. This one about how this backdoor tried to mimicry by TLS protocol, and it uses some bytes which use usually in TLS protocols. So even Wireshark say you that it's TLS, but it's not TLS. In the screenshot below, you can see plain text user PC, and I will show you some decryption from Cyberchef. So TLS client packets really have a larger service packet because the client initiates the connection and provides an additional data. So it's one of the methods we can check the length of packets. So if we will show more detailed, we can see that 3 first bytes, it's magic bytes, really it's used in TLS. I think you know about it. The next 2 bytes is size of packet, and 32 bytes is XOR K. And the last bytes, all the last bytes, it's just decoding bytes. So using Cyberchef, we can decode it and see that this is desktop and the name of computer. So also we can decrypt other bytes, and how we can detect it. Here, this example is a really good example for network rules when we know about malware. So it cannot help you to find new malware, but it will help to find to detect already known malware. So for this family, for example, we can write two rules which connected with flow bits. Flow bits is a keyword of Suricata language. It's Suricata rules, and these keywords connect rule 1 and rule 2. And in first rule, we check stream size, we check content, which are always the one, because this is magic bytes, which not changed. And in the second rule, we also checked content and write flow bits to connect. And also we use threshold for make these rules try to check counting and in seconds for 1 minute, because we can detect TLS protocol, but we don't want to detect TLS protocol, so we need to write good rules for detect only malware without falses. And other good technique is deep parsing mechanism for protocols and application. So we can see that in Wireshark, it said us that it's TLS, but if we will check more bytes and check them, so we can understand that it's not TLS. And for some solutions, we can make this. It's about coding, about programming, not about just analyzing and write the text. So it's really help to understand and find mimicry. Another technique is DNS tunneling. Here example from the loader. It's not old, I think half a year. This is from this color, because I don't see. This color made a report, and they describe how it works. So DNS tunneling technique is about when you try to send some not DNS bytes in DNS protocol. And here you can see some format structure, how the hackers try to send the loader. For example, there are some prefix, header, payload, and the loader name server domain. So if we will check using some repetition lists, they can change it. But if we will try to find this using lengths between subdomains, so it helps to find different whereas the loader, not only this. So we see here that the length of some subdomains the same. So it's one of example how we can detect it. Another example of DNS tunneling is decoy-doc malware. Here you can see the full big chain of communication, but here is DNS tunnel. So in DNS tunnel, there are also some big length of one subdomain and for second subdomain. So if we will check using some fuzzy hash and try to calculate length before the first one, the second one subdomain, check which symbols are used. We also can try to find it because, you see here that CloudFront, it's not real domain for CloudFront. It's fake CloudFront, but actually they can change this domain. Another methods for this, we can search for anomalies, how I said before, in DNS packet bytes. We can use for it email or behavioral profiling. Also, we can analyzing the number of requests and the gaps between packets using script models. And we can search for requested resources via database of IOCs, reputation lists. Sometimes we can use network rules, but I don't think that it's a good idea for this technique, because it will work only for specific malware families, and you cannot find the new one. Other technique is unknown protocols. Here, GDP door. It's a Linux backdoor. Maybe some of you read about this. This backdoor is known because it used for communicating C2 traffic over GTPC, GPRS tunneling protocol. So here I added some SIM, how it can communicate. So it sent some packets in ACK and some signaling messages. So it's really interesting to try to find it and try to detect, because it's difficult, really. And if we will see in the network packet, so we can see some bytes which can say us that it's GTP. So we can try to write network rules like some ports and protocols, but there are SCADA systems or ICS system where it can be used, and it's okay. So for finding not only GTP, for just another unknown protocols, it's not a good choice, because it's, for some systems, not only ICS, they have a lot of specific protocols, so these methods will not work. There are a lot of falses, so you need to make it carefully. I think here there are more good choices. There is a reparsing mechanism for protocols and applications, and make solutions for specific system, and behavioral PC profiling. So if user every day have some communications with some unknown protocol, but it can be okay for some application or for some system, so it's really okay. We don't need to make alerts for this. Another one technique is steganography. Here example of famous campaign, Steganography. It's alive now. And it's alive already more than 1 year. There are really a lot of traffic, or a lot of network packets, which I see every day. So how it works, this Steganography campaign. They have a big chain for downloading some web scripts or other scripts, some image which contain some payload. Here, for example, on the right, base64 payload, but they use another encryption. So how we can detect it? On the left, you can see that the client ask about GIF for server, and server sends not GIF. He sent some WebS bytes. And GIF have the last letters in uppercase, so it's really not usual. For the right screenshot, we see that clients ask about JPEG file, and server send content type with image JPEG, and it sends GIF, but in the ending of these packets, we see base64 payload, and TVQ is the start of PAF file, but in base64. So we can try to make some network rules for some specific network families. For example, for this, we can detect using some content with distance and within keywords, and we can make PCRE regex for this, but it's not only one way. So I think the good choice here is checking for file type mismatches and analyzing anomalous internal content using some signature analysis as above, files analysis in sandboxes, and advanced analysis ML. So if we will send, for example, our GFIF file from here with base 64 start, yeah, it depends on sandbox, but there are some sandbox which can detect it and show that it's not okay. The next technique is about not standard encryption, it's about custom encryption or compression and encoding. I collaborate 3 of them, and here are examples of 2 RATs, XORM RAT and Incher RAT. And if we will see on the screenshots, I'm not sure that you can see, but I highlighted in red color the first bytes of packets, which say us that this is length of packet. So first packet, for example, of XORM RAT is a packet which contains length, after this 0 bytes, and after this, this length of some encrypted bytes, but this is IS, and we can check another packets, and we will see that they have the same structure, so we can try to find in the traffic packets, streams with a lot of packets, which contains the length, 0 bytes, and after that, this length of bytes. For Incher RAT, the same situation, but it uses not only IS, but also another some bytes which it include inside the packets to make analysis and detect more difficult. For example, you can try to see on the right page in the first packet Win 10 Pro or Windows Defender. So yeah, and here the same situation, because the first 3 bytes is about length of packet, the next byte is 0 byte. So also for server answers, server packets, the same. About compression, because it's in this technique also. Here another malware. I decided not to write here malware because there are really a lot of, for example, ghost malware, PCRAT, it's ghost, and another one. So they use the lib and zip compression. The lib bytes you can see on the left page, and zip compression on the right of this screen. So we also can try to find, but we need to remember that a lot of legitimate tools can use the lib and zip compression. So we can try to decompress it and analyze what we can see inside it. So we can use for these techniques network rules using threshold and flow bits, for example, for packets which contains length with 0 bytes. Also PCRE, but not for XORM. I think threshold and flow bits is okay. We can try to use stream sizes and byte tests and byte jumps, so etc. For script models, they are really more flexible for finding this. So we can try to find packets not only in streams, it's like X bits in Suricata language, but in different streams, and understand what can hide inside some compression bytes or encoding bytes. And we can use the lib and zip compression functionality in the solution. Other technique is frequency of sending malicious packets. It's about, I remember that yesterday was a report about Mirai. So here are some packets of Mirai. They have a lot of packets, and we can see, for example, that number of one of stream which collect around 2 minutes is more than 700 total streams, and for 3 minutes is more than 8,000 streams. So we can use for this thresholds and X bits, and we can check number of packets for a certain time. So how you can see on the image, try to make some behavioral PC profiling. Next, before the last technique is packet fragmentation, and I collaborated with data littering. It's about when hackers try to add some data littering. If hackers try to add some trash bytes into the packets, like here, and packet fragmentation, it's another situation when hacker try to divide packet for the small packets. So how we can detect it? For packet fragmentation is use network rules for full streams and not for single packets. And many small packets is an anomaly, especially if they are same length. So it's about advanced analysis and the methods from advanced analysis. For data littering is ML solutions or script models. And the last technique is encrypted traffic. It's about all legitimate encryption. So VPN, TLS, HTTP2, it became more popular on hacker. It's bad for network analysts because not a lot of solutions can detect it, can decode it. So we need to make more good solutions for it. So we can write some network rules for specific VPN and proxy. We can use script models for checking packet lengths, combination behavioral profiling and ML solutions, and make some deep parsing, not only for HTTP protocols, but for others. And in the conclusion, I want to say this phrase, that any obfuscation technique by an attacker can be detected. It's not always necessary to use advanced methods, such as ML. Often simple rules are sufficient. And the proper allocation of protection resources for detecting different obfuscation technique with multiple methods will allow to effectively detect current and new threats in the network. So thank you very much for your attention. Here you can see my Twitter and my LinkedIn, but I hope we have time for questions.
One question. So it's got to be a good one.
Yeah, I get one. In fact, thanks for the presentation. It was very good. For the machine learning and frequency analysis, have you researched on the distribution of the frequency of packets? Do you have elements on what kind of statistics approach is efficient when you're looking for C2 domains?
Do you mean which statistic for?
Yeah, which kind of methods you can use, when you're looking for C2s in a lot of traffics, or do you have inputs or insights on how it's...
So actually, I spent a lot of time for find more, libraries for make good ML solution. For my ML solution, I used just light GBM library, but I'm know that there are more good. And about statistics, for my first trying to make ML solutions, it was 99.999%. But after making some checking and adding more bytes, more packets and more packets, this number, yeah, more or less, because when you make your ML solution not in your home system, but in the wild, it's more not, you cannot understand how it will work, and there are some falses, yeah.
Thank you very much.
Thank you.
Okay.
If you will have some questions, you can ask me on the coffee break, so thank you.
Thank you, Kseniia.
Thank you very much.
Thank you.